Yeah, hello everyone. My name is Professor M.N. Karimi. I am from Jamia Millia Islamia, and it is continuation series of the lectures that I am trying to put on the website in order to understand basics of air conditioning processes. And this is after when you view the lecture of room sensible heat and dew point temperature, which is related with psychrometry. So now moving on and trying to understand another step in understanding the air conditioning process on psychrometric chart. I have once again taken the same room which we have been discussing about the window air conditioner. I have taken a typical window air conditioner. It can be changed to any other system where it is written on books, but I have preferred taking this to make you understand another factor today. Now this is a window air conditioner as shown, and we have a room which is on the black spot, and this room has got a fixed parameters. The parameters are being frozen, and it has been found that there is a certain wall thickness, there is a certain orientation of north, south, east, west, and there is a certain amount of load on this particular room. Any room can be identified in any designed structure, or built structure, or proposed structure, and then one can understand that this particular room is for a certain purpose, and there is a certain amount of load in the form of sensible heat and in the form of latent heat, which I have explained earlier. And once we come to know these two things, then we define what is known as room sensible heat factor. So I have said that room sensible heat factor is equal to room sensible heat upon room sensible heat plus room latent heat. So once we have these, then we have a fixed value of, on the last lecture I took it as 0.8. What does this 0.8 represent? That there is a certain fixed value calculated for this particular room, and it has got a fixed value of room sensible heat and fixed value of room latent heat. So every room will have its own typical value of room sensible heat factor, and once it is known, then the steps which we have to follow is like this. So if you see a psychrometric chart, this is a typical psychrometric chart, and if you see that, then you see on this side there is a table which is writing sensible heat factor. It starts from the value of 1.0 and this goes on decreasing and becomes lesser. So the least value is not given. Now if you see the definition of room sensible heat factor, it is ratio of room sensible heat and room latent heat. So you can make it out that if the room latent heat is equal to 0, then the room sensible heat factor is equal to what? When this becomes 0, then is equal to 1. So what does that mean? That room sensible heat factor will become 0 if there is no latent heat load. Means this room will have not produce any amount of humidity in this area, and therefore the air conditioner will not be the air will not be having any problem of latent heat or problem of any humidity which has gone up or gone down. So there is no humidity factor here. If it is not a humidity factor, if room latent heat becomes 0, and the room sensible heat factor becomes 1, then you can see that if you see 1.0 room sensible heat factor, then you see this line. You see this line, how it is moving. If you see this line, then you will see that it is moving and zeroing down at a certain value of relative humidity. See 50% relative humidity, and you see 25 degrees centigrade dry bulb temperature. So this particular point, which has been said to be room design condition. And this room design condition is the point on which if you draw a horizontal line, you see, if you take this as a room design condition, 25 degrees centigrade dry bulb temperature and 50% RH, then from this particular point, if you draw a horizontal line which is at constant humidity, without change in humidity, without load of humidity, then sensible heat factor is equal to 1.0. This means that if you draw a horizontal line here, this line will represent room sensible heat factor 1. And surprisingly, it is passing through a point called design point, which is at 25 degrees centigrade dry bulb temperature and 50% relative humidity. So this particular point is called room design, and we generally write down in our theoretic classes that room design is generally taken as I. So what is I? Small I is 25 degrees centigrade dBT and 50% RH. So if you take that value without looking at what is the problem is, then you just take 25 degrees centigrade dry bulb temperature, and you can say this is a line which is having 50% RH. Then you will be able to take from here, you take a line which is just 25 degrees centigrade, and on 50% RH you will see that this is a point which is having what? Room design. So a room design condition can always be looked upon or can be plotted on the psychrometric chart like this and say, okay, this is the room design condition. So room design condition is already there denoted by a small circle on some psychrometric chart. So it is clear that if we have room sensible heat factor not equal to 1, then, or we have found out for this particular room it is equal to 0.8, because there is a certain amount of room latent heat load available inside the room. Means there is somebody inside this room who is breathing out air which is containing humidity, and there is something which is producing steam over here. There is some infiltration from the door, if you see the last lecture. So because of this, or some fresh air is coming from outside, because of this contribution there is a certain amount of room latent heat load, because of which room sensible heat factor is coming out to 0.8. Now let us look at the process of drawing this particular thing, plotting it. Once you have calculated the value of 0.8, then what you will have to do on this particular scale, where the value of 0.8 is there, just take a point here and make a circle. I will show you. So from this particular scale, see as 0.8, and from here you make a circle. You see, I have made a circle here, and we have already made a circle here which is room design condition. So if you see what I have done on this paper, without spoiling their psychrometric chart, which is the original one, 0.8 circle is there, I condition circle is there. I have put on a scale and trying to draw a line. So I am drawing a line which is like this, but I am not stopping at I am continuing from this, passing through I, and let it go farther, and it is passing like this. So I have drawn a line which is like this, see, like this, starting from here, passing through I, and then passing it like this. This is the whole line I have drawn. Now on this whole line, what is the value of room sensible heat factor? 0.8. Everywhere it is 0.8. So this is a 0.8 line, room sensible heat factor line. This line is a 0.8 because it is passing through the design condition. So if you draw this line, then it will pass, but it cannot, the significance of having any process line is up to the saturation curve. So if we want to draw a line, it has no significance. It has to stop or end. Any process has to end. So if we have to draw a line, if it is coming from 0.8, so it will come here and it will go, and then it will cut somewhere on the saturation curve, whatever point it is. So in respective, I'm not taking any value right now. So it is cutting here, by the way, at this particular point. So this particular point, see, this series of discussion will go on, and I will go on changing my statements as per the knowledge given, or you may have better knowledge, but I would like to speak in a step-by-step manner, where I am now considering that this is the point which is ADP of the coil. That is the ADP of the, which is the coil temperature. So this is a cooling coil and its temperature is TA. What is TA? TA is this is evaporator and this is the condenser. Condenser is rejecting heat. So evaporator is taking the heat of the room and cooling the air here. So so this is the evaporator temperature. So the method of finding out what will be the evaporator temperature is to draw a line and then let it pass, and this particular point will be the apparatus dew point temperature. On this particular lecture, I will change it in another lecture as we learn more, but we will consider this as our apparatus dew point. So this is the coil temperature. This is what? TA. Don't misunderstand if I have written S over here. That will come into picture. So here there is, I am just saying, there is this for 0 BPF. We will discuss in another lecture. Now, when we have drawn that line, we now have another thought. The air of the room, when we were somewhere out in the market and now we have come at 1 o'clock to this particular room in summer and we want to put the AC on. So whatever is the temperature outside, we will think that the temperature of the room is also same, because the AC was not working at that time. So O stands for outside temperature, or O stands for the temperature of the room when it was closed, the AC was closed and it has just been put on. So when we put the condition of the room which is similar to outside condition, we will say O and R are same. Outside condition and room condition is same. Now in previous lecture I said the room condition was different. Now I am saying outside and room condition are at a higher value. Now let this particular value of room condition be having a certain higher temperature, very high temperature. This is a very high temperature and very high value of enthalpy. So enthalpy is also very high and the temperature also is very high. Temperature is very high. So when we put the AC on, what will happen is this room air will go, or the same condition is outside condition, room condition is the same, it will go inside the cooling coil, and surprisingly here for this lecture's sake it has converted itself from O to the temperature of the cooling coil. It's the same way I have spoken in my previous lecture. See, gradually I will change my statement in another lecture. So O has converted into TA. So what has happened is outside condition has converted into coil temperature. So we have understood in previous lecture there was a line like this. Okay, so this particular process is what? Cooling and dehumidification. All the room air has got converted into the temperature of the cooling coil perfectly. It goes and then it becomes it becomes exactly the same as the cooling coil. So this is the temperature. Now the air has, from this condition, it has converted itself to a very low temperature. Previous lecture I took it as 4 degrees centigrade. So this is 4 degrees centigrade. All the air is now, when it has come in contact with the cooling coil, so air comes, cooling coil, O condition or R condition comes, in the cooling coil is 4 degrees centigrade, it becomes 4 degrees centigrade. What is the temperature of the air? 4 degrees centigrade. What is the condition of the air? This. When it is coming out of the cooling coil. So when it is coming out of the cooling coil, its temperature is what? Same as the cooling coil. Means when it's coming means supplying itself to the room. So S and TA are considered to be the same point here. What is S? S represents supply. What is TA? Temperature of the cooling coil or apparatus dew point temperature. So S and T here we have considered as same. Supply condition which is coming out of the AC going inside the room is same as 4 degrees centigrade. This is what we have assumed. Okay. So what has happened is the air comes, gets cooled, become TA and gets now supplied to the room. So when this S condition air which is at 4 degrees centigrade is now entering the room, okay, then what will happen is that 4 degrees centigrade air, when it comes inside the room, then also this particular room will be producing a certain amount of heat in the form of radiation coming from the wall, radiation coming from the window, radiation coming from the doors, appliances, occupants, and all the things which we have discussed earlier in the form of room load, that is room sensible heat and room latent heat. So the room will be going on every time, all the time, producing certain amount of room sensible heat and certain amount of room latent heat in the same manner of the ratio which we have calculated as 0.8. It will be going ahead to produce sensible heat and latent heat. The room will go ahead producing sensible heat and latent heat in the manner that this particular formula of 0.8 will hold good every time, all the time. So what will happen is when this condition S will come inside the room, S condition will now change because of the reputation of the room. The room has a tendency of producing room sensible heat. So sensible heat will push here the temperature and latent heat will push here the temperature up. Sensible heat addition to S condition for 10 degrees centigrade will push the temperature higher and the latent load will push the humidity higher. It will follow a line which is equivalent to 0.8 room sensible heat factor, and therefore it will follow a line which is having the same value of room sensible heat factor 0.8. You see? So S condition will gradually increase in humidity and increase in temperature. The supplied air will gradually increase in humidity and temperature as it will go ahead taking the room sensible heat load and room latent heat load in the manner of such that this formula of 0.8 satisfies. Therefore, it may have come through a certain process route which is a certain line, but it will follow one particular route and one particular line only, which is 0.8 room sensible heat factor loop. This is the 0.8 room sensible heat factor value. So it will follow a line. Therefore, we will say that this particular line which is following room sensible heat factor of 0.8 is known as room sensible heat factor line. What is this? S2I is what? Room sensible heat factor line. What this line is what? Is dependent upon a certain sensible heat factor, which is obviously a room sensible heat factor of 0.8, and because it is passing through a process represented by a line, this line will be known as room sensible heat factor line. And this line is called as grand sensible heat factor line. So let me define two lines. Grand sensible heat factor line is the line in which air which goes through the cooling coil, and converts itself from any condition towards the cooling coil condition. Air of any condition passes and converts itself towards or to the coil condition. So what has happened? Air of outside or room condition is converting itself and moving towards a temperature which is cooling coil condition, and in this case it has become same as cooling coil temperature. That particular process line will be known as grand sensible heat factor line. Okay, so it is air which is coming and going inside the cooling coil and converting from anywhere. If the air is coming and passing through the cooling coil and becoming something, that conversion will be represented by grand sensible heat factor line. Second process, when the air comes out of the cooling coil, getting supplied to the room, then this air, which is at a very low humidity and very low temperature, adds in temperature, adds in humidity, and increases its humidity and temperature. Therefore, it humidifies and gets heated up, and during this process it follows a line which will be having fixed value of room sensible heat factor and converts itself to, this is important, and converts itself to the final destination of room design condition and not beyond it. It will stop at this particular condition. So the train starts from here and ends here, not beyond. This particular small line is known as room sensible heat factor line. This particular dotted line I have drawn in order to facilitate the making of the line. So we take point 8, we pass it through I and pass it and then cuts the saturation curve, but the important line is from here to here only, up to room design condition. This line is of no importance. It is just a helping line in order to. So what are the processes? This is one of the process. This is one of the process. So today I have tried to explain you what is the significance and meaning of and the method of drawing room sensible heat factor line and grand sensible heat factor line. I hope it is clear, and we will continue in coming lectures. Thank you very much.